August 2025. The James Webb Space Telescope detects a 4-hour thermal pulse from 3i8-lus. Regular, mechanical, unexplained. To October 2025. MAVEN at Mars detects the same 4-hour cycle in magnetic field oscillations. Same period, same rhythm. 2 months apart, 2 different instruments, same signal. So here's what we know. Natural comets don't pulse on precise schedules. Solar heating is random. Outgassing is chaotic. Rotation periods don't match. Yet 3 Atlas cycles every 4 hours like something operating, like something scanning, like something transmitting. And here's what we don't know. What's causing it? Why 4 hours specifically? What happens during each pulse? And why, when amateur astronomers worldwide confirmed the cycle with their own observations, did NASA, ESA, and every major space agency stay silent? No official papers, no press conferences, no acknowledgement that an interstellar object is behaving like a machine with an operational rhythm. Because if they admit the pulse is real, they have to explain it. And right now, every natural explanation fails, which means the answer might not be natural. And that's not something institutions are ready to say. Before we dive into the data, a small ask. If you find this investigation valuable, if the questions we're raising matter to you, consider hitting the like button. It helps more people see this content. Drop a comment with your theory. Natural or artificial, I read them all. And if you want to stay updated as this story unfolds, subscribe and turn on notifications. We're covering what mainstream channels won't touch. Your support makes that possible. Now, let's talk about the heartbeat. The 48-hour observation window. On August 6, 2025, the James Webb Space Telescope's near-infrared spectrograph, NIRSpec, began a continuous observation campaign of 3i8-lus. The object was at approximately 4.4 astronomical units from the Sun, still relatively distant but active enough to emit detectable thermal radiation. Webb captured infrared frames every few minutes over a 48-hour window. The goal: measure the comet's thermal signature, identify volatile composition, track outgassing activity. What came back was unexpected. The thermal pulse infrared brightness fluctuated, but not randomly, not in the chaotic, unpredictable way comets typically behave as they tumble through space, exposing different surface features to sunlight. Atlas pulsed, the core brightened, peaked, dimmed. Then, 4 hours later, it happened again, and again, and again. Dr. Lena Marovich, senior instrument scientist on the NIRSpec team, ran time series analysis on the data. She plotted thermal intensity against time. The result was a sine wave, smooth, regular, repeating, period, 14,400 seconds, exactly 4 hours. In leaked internal communications later shared on astronomy forums, Marovich wrote, "This is the most organized thermal signature I've ever seen from a comet. It doesn't behave like outgassing. It behaves like a clock." Fourier analysis. To confirm the signal wasn't a processing artifact, the team applied Fourier analysis, a mathematical technique that decomposes complex signals into their component frequencies. If the brightness variations were random noise, the Fourier transform would show a broad, flat spectrum, energy spread across many frequencies. Instead, it showed a sharp spike at 0.000694 Hz. That's the frequency corresponding to a 14,400-second period. 4 hours, no drift, no harmonics, just one clean dominant frequency. That's not how natural processes work. Natural thermal cycles, driven by rotation, by solar heating, by surface irregularities, produce messy signals with multiple overlapping frequencies. Atlas produced a single tone. Pure, unwavering, the rotation problem won. Obvious explanation for periodic brightness changes is rotation. As a comet spins, different sides face the sun, and if one side is more active or reflective, Brightness will vary with the rotation period. But 3-Atlas rotation period, measured from light curve observations over multiple nights, is approximately 22 hours, not 4. If rotation were causing the pulse, we'd see a 22-hour cycle, not a 4-hour cycle. Some researchers proposed that the nucleus might be tumbling, rotating around multiple axes simultaneously, which could produce complex periodicities. But even tumbling bodies don't generate single, perfectly regular frequencies unless there's a dominant axis or a specific geometric configuration, and 3I Atlas's 4-hour pulse is too clean, too consistent to be explained by chaotic tumbling. The outgassing hypothesis. Another natural explanation: periodic outgassing. Perhaps subsurface ice is vaporizing in pulses, driven by some internal heating mechanism that cycles every 4 hours. Problem: what internal mechanism? Solar heating is steady and external. It doesn't turn on and off every 4 hours. Subsurface heat conduction is slow and diffuse. It doesn't produce sharp regular cycles. Radioactive decay? Constant, not periodic, tidal heating. 3-Atlas isn't orbiting anything massive enough to generate tidal forces. Chemical reactions? Even exothermic reactions don't spontaneously cycle with 4-hour precision over weeks. Every known mechanism for cometary activity is either constant, random, or tied to rotation. None produce a 4-hour thermal pulse. 2 months after Webb's detection, 3-Atlas passed Mars, and MAVEN, the Mars Atmosphere and Volatile Evolution mission, was watching. MAVEN's mission, MAVEN, wasn't designed to study comets. Its job is to measure Mars's upper atmosphere and how the solar wind strips it away. But MAVEN carries a magnetometer, and as 3-Atlas made its closest approach on October 3rd, the instrument detected something unusual: the magnetic oscillation. The interplanetary magnetic field, the extension of the Sun's magnetic field that permeates the solar system, fluctuated, not wildly, not chaotically, in regular pulses. Every 4 hours. MAVEN's magnetometer recorded oscillations in the magnetic field, strength, and orientation. The variations weren't large, but they were measurable and consistent. Dr. Stephen Burns, a geophysicist analyzing MAVEN's data, noted in internal team discussions, "This doesn't match solar wind variability. It's too regular. It's synchronized with something else." That something else, as cross-referencing with Webb's timeline revealed, was 3I Atlas's thermal pulse. The cross-validation: 2 independent instruments, 2 different types of measurements, same 4-hour period. Webb measured thermal emission, heat, radiating from the nucleus in infrared. Wavelengths: MAVEN measured magnetic field, changes, distortions in the ambient interplanetary field as 3-Atlas passed. Nearby. These are fundamentally different physical phenomena. They shouldn't be linked unless there's a common cause. But they are linked. Perfectly. Every time Webb detected a thermal peak, MAVEN, 2 months later, detected a magnetic oscillation at the same phase in the 4-hour cycle. What magnetic pulses? Mean magnetic field disturbances around comets aren't unusual. As the solar wind, a stream of charged particles, interacts with the ionized gas in a comet's coma, it can create bow shocks and field line draping. But those effects are continuous and tied to the comet's interaction with the solar wind. They don't pulse on internal schedules, unless something inside the comet is generating periodic magnetic activity. Possibilities: electromagnetic systems. If 3I Atlas contains conducting materials and internal currents, it could generate its own magnetic field. If those currents cycle on a 4-hour schedule, perhaps tied to a power system or operational mode, the external magnetic signature would pulse accordingly. Plasma release. If the comet periodically releases bursts of ionized gas, those plasma clouds would interact with the interplanetary field, creating detectable oscillations. Rotating magnetic structure. If the nucleus has a non-uniform internal magnetic field and rotates with a 4-hour period, separate from its 22-hour surface rotation, that could produce external pulses. But all of these explanations require something highly organized, something that doesn't occur naturally. While Webb and MAVEN provided the headline data, the real validation came from independent observers. Bill Gray's network. Bill Gray, developer of widely used orbit calculation software, coordinates a global network of amateur astronomers. When rumors of the 4-hour pulse began circulating on forums, he put out a call: track 3i Atlas, measure brightness, log timestamps. Volunteers from Australia, Japan, Europe, South America, and North America responded. Using backyard telescopes ranging from 8-inch reflectors to 16-inch Schmidt-Cassegrains, they captured photometric data night after night. The light curves each observer generated light curves, plots of brightness versus time. Individually, some curves were noisy, affected by atmospheric turbulence, moonlight, and instrument limitations. But when the data was compiled and cross-referenced, the signal emerged. The atlas brightened and dimmed every 4 hours, consistently. One observer in Japan noted, "I thought my tracking was drifting. The brightness kept cycling in a way I'd never seen." Another in Australia. After 3 nights, the pattern was undeniable. Every 4 hours, like clockwork. The validation process. Bill Gray's team applied statistical analysis to the combined dataset. They calculated average light curves, filtered out noise, and tested for periodicities. Result: a 4-hour cycle with high statistical significance. The probability that this was random noise? Less than 0.1%. This wasn't instrument error. It wasn't confirmation bias. It was signal, and it matched Webb's thermal data and MAVEN's magnetic data perfectly. The community reaction astronomy forums lit up. Threads on cloudy nights, Stargazers Lounge, and Reddit's R Astronomy filled with debate. Some argued for natural explanations, complex rotation, asymmetric outgassing. Others pointed to the precision and asked, what natural process maintains 4-hour cycles over months? One comment summarized the mood. We've observed hundreds of comets. None of them do this. Either 3 Atlas is the weirdest natural object ever, or it's not natural. What could cause a 4-hour pulse? Let's systematically examine every plausible explanation. Hypothesis 1. Complex rotation. Perhaps. 3. Atlas has a complex rotational state, tumbling around multiple axes, that coincidentally produces a 4-hour observational cycle. Problem: tumbling produces irregular, quasi-periodic signals, not clean sine waves. The Fourier analysis would show multiple frequency peaks, not a single dominant spike. Moreover, maintaining a stable 4-hour tumbling mode over months, despite outgassing torques and tidal effects, is dynamically unlikely. Hypothesis 2. Subsurface geysers may be there. Are subsurface chambers filled with volatile ices that erupt periodically as pressure builds and releases. Problem: what mechanism creates 4-hour pressure cycles? Geysers on Earth, like Old Faithful, have periodicities driven by water recharge rates and thermal conduction. But those processes take hours to days and vary with environmental conditions. A 4-hour cycle maintained with precision over months would require a feedback system, something that senses pressure, triggers release, waits exactly 4 hours, and repeats. That's not geology. That's engineering. Hypothesis 3. Orbital resonance. Could some external gravitational or tidal force be driving the cycle? Problem: 3 Atlas is on a hyperbolic trajectory, unbound to any massive body. It's not in resonance with anything. The nearest planet during Webb's observation was Mars, still millions of kilometers away with negligible tidal influence. Hypothesis 4. Solar wind. Interaction, Perhaps periodic variations in the solar wind create pulses in the comet's activity. Problem: solar wind variability is random and event-driven. Coronal mass ejections, solar flares. It doesn't produce regular 4-hour cycles. And even if it did, why would 3 Atlas respond on a 4-hour schedule when other comets don't? Hypothesis 5. Internal power cycling. Now we enter uncomfortable territory. What if the 4-hour pulse is operational? Imagine a spacecraft. It has systems: power generation, data collection, transmission, thermal management. To conserve energy, it cycles through operational modes. Mode 1. Active, 30 minutes. Power up. Collect data. Scan environment. Transmit, Mode 2. Dormant, 3.5 hours. Power down, non-essential systems. Conserve energy. Process data. Repeat every 4 hours. This is how real deep space probes operate. Voyager, New Horizons, Cassini. All cycle power to manage limited resources. If 3I Atlas contains a power source and operational systems, a 4-hour duty cycle makes perfect sense. But that's not a comet. That's a probe. The institutional silence. So why isn't this front-page news? No official papers as of October 2025. No peer-reviewed publication analyzes the 4-hour pulse. Webb's thermal data remains in internal archives. MAVEN's magnetic findings appear in technical logs but not scientific journals. Amateur network results circulate on forums and preprint servers, but mainstream institutions haven't engaged. The vague statements NASA's Goddard Space Flight Center, which operates Webb, issued a brief note in September. Continued analysis of 3 Atlas observations is ongoing. Preliminary findings suggest complex activity patterns. Complex activity patterns. That's it. ESA's blog post on MAVEN's Mars flyby observations mentioned interplanetary field variations, with no elaboration, no mention of the 4-hour cycle, no discussion of the cross-validation between Webb and MAVEN, no acknowledgement of amateur confirmations. The leak culture. The only detailed information comes from leaks, internal Slack channels, forwarded emails, screenshots of data plots. Scientists within these institutions are talking about it, privately. Some are excited, some are skeptical, but none are publishing. Why? The uncomfortable question. If NASA or ESA officially acknowledges the 4-hour pulse, the next question is inevitable. What causes it? If every natural explanation fails, and they do, the only remaining category is artificial. And that's a claim that requires extraordinary evidence. Publishing a paper that suggests an interstellar object might be a probe invites intense scrutiny, career risk, and public panic. So institutions stay quiet. They gather more data. They debate internally. They wait for a natural explanation that fits, but the data doesn't change. The pulse continues. And the longer they wait, the more the silence itself becomes the story. The heartbeat metaphor. Why do we call it a heartbeat? Because the metaphor is powerful and unsettling. Heartbeats are biological. They're controlled by pacemaker cells that fire with electrical precision. They're organized, regular, essential for life. When something pulses with mechanical regularity, we instinctively recognize it as a sign of organization, of control, of life, and the Atlas pulses every 4 hours. Not approximately, not on average, exactly. That precision is what makes this so profound. Natural chaos doesn't produce clocks, but systems do, organisms do, machines do, and whether 3I Atlas is biological, mechanical, or something we don't have words for yet. The 4-hour heartbeat tells us one thing with certainty. It's not random. It's operating. Conclusion. Listening to the Rhythm August 2025. Webb detects a thermal pulse. 4 hours, repeating hot October 2025. MAVEN detects a magnetic pulse. 4 hours, same rhythm. September-October 2025. Amateur astronomers worldwide confirm the optical pulse. 4 hours, consistent. 3 independent lines of evidence. Different instruments, different measurement types, same cycle. And the institutions that operate these instruments, silent, no papers, no press conferences, no explanation. Because the 4-hour pulse doesn't fit any natural model. And the alternatives, artificial power cycling, operational duty cycles, designed systems, aren't conclusions science is ready to draw publicly. But the data is there. The rhythm is real. The heartbeat continues. Subscribe to Narrator of Shadows. Because when an interstellar visitor arrives with a pulse, someone needs to take its vital signs. The heartbeat is steady. The cycle is precise. And something, somewhere inside that icy nucleus, is keeping time. 4 hours. Every time. Like clockwork, or like something alive.